Hi everyone, just wanted to take a minute to talk a little bit about how to solve quadratic equations using square roots. So when you're looking at quadratic equations, there's a specific situation that you could run into that will make your, solving capabilities that much better. And it's going to be the situation where b is equal to 0. All right, so when b is going to be equal to 0, you're largely going to end up in a situation where you can use square roots. The only time that you're going to be using square roots in with solving quadratic equations, and b is not 0, is going to be if you end up with a perfect square trinomial. All right, but in general, it's going to be when b is equal to 0. So what are you going to do? Well, you could end up with a situation like this. X squared is equal to 49, which, if you wrote it in standard form, would be like this. X squared minus 49, okay, would be equal to 0. So when you take the square root of both sides, right, you could rewrite it so you get x squared equals 49. Well, I know that if I have a number squared and it equals 49, I have two options, right? I have 7 or I have negative 7, right? So if I took the square root of both sides, you would get 7. But you also have to keep in mind that negative 7 is a viable answer for this purpose, right? We're just talking about the general x-intercept. There's no problem with an x-intercept being negative 7. So we do have to include both the positive and the negative solutions. All right. So what would actually happen if you ended up with something like this, though? So if I had it written the other way, right, plus 121, even though this looks like it's nicer than something like, let's say, this one right here, that's going to have two solutions, negative 11 and positive 11. This one is going to have no real solutions, right? If you try and take the square root of this, you're going to get the square root of negative 121. Well, there is no real number there's no real number where you would get the same things multiplied together and you'd get a negative number, right? Because if you know you have a negative times a negative, it's a positive. And if you had a positive times a positive, well, it's still a positive. So there's no way you're going to end up with a negative times a negative is equaling a negative, or a positive times a positive equaling a negative, right? You need to have one be positive and negative, but that would mean they're not the same. So that's why if you get something like this, you'll actually have no solutions, no real solutions, I should say. There is a way that you'll be able to do this with imaginary numbers, but for our purposes at this time, there's no real solutions. All right, so if you did something like this, right, we want the square root of 169, you have plus or minus 13. If I took the square root of this, I would have the square root of negative 16, which we cannot solve using the methods we know thus far, so there is no real solutions. All right, so you would have no real solutions. All right, now what if it's not a perfect square? Well, I think you kind of already know the answer to this, right? If it's not a perfect square, we're going to use exactly what we just learned about in terms of simplifying radicals to simplify it as much as possible. All right, so you want to simplify it as much as possible. I don't want to see you leave something with like the square root of, 8, right? I think they actually do once, and I don't know why they did it, but there is actually, you don't want to leave something with like the square root of 8 because you can simplify that more. All right. So for example, here, I have x is equal to plus or minus, don't forget both positive or negative, the square root of 28. Well, what's 28? Well, that would be the square root of 4 times the square root of 7. So you get 2 root 7. Now, so you have two answers, right? You have positive 2 square root of 7 and you have negative 2 square root of 7. All right, so these are your two solutions. If you graphed it, this would be where they would where they would be. All right, now you get something like this. X equals plus or minus the square root of 252. Now, let's try and find different things that go into 252. Well, what do we know? 252 is divisible by 4, right? That's 63. Let's write that. X equals plus or minus 4 square root of 63. Now, it's tempting to leave this as an answer, but we already know 63 can be broken into 9 and 7. Oops. Okay. plus or minus 2 times 3 root 7 plus or minus 6 root 7, which indicates to me, by the way, that at the beginning, when I did 252, I could have divided that by 36 and would have just gotten 7. All right, so if you saw 36 right away, you could have done that and been on your way. If you didn't see it, that's okay. All right. Now, what if you already have a number in front? Well, I think you kind of know the answer to this problem. You're going to divide, right? And if you can, simplify. If you can't, leave the fraction. I think for our purposes, they're going to be able to simplify. Now, looking at this, don't be scared. Your first instinct when you see the negatives is, no real solutions, but both sides are negative, so when you divide the negative out, it'll cancel. Now, for reasons I have not fully figured out, they did leave this one as the square root of 8, but you should not. Don't do that. So x would be plus or minus, right? That's the same as 4 root. Okay, right? So it would be plus or minus 2 root 2. That's what they should have left it as. Right? But remember, simplify first, because otherwise, if you don't simplify, you're going to have something like this, the square root of 24 over the square root of 3, and you're going to look at me and go, I don't know what to do with the square root of 3, mister. Well, as it turns out, if you simplify it from here, it will still all cancel out, but just be careful with that, please. All right. So, for example, if you have something like this, right, divide by the 5 first, you get 25. So you get x equals plus or minus 5. Now, with something like this, multiply both sides by negative 2. That'll cancel that. You'll get x squared equals 72. So x is going to be equal to plus or minus the square root of 72. Well, conveniently, I already know that 72 is 36 times 2. So that is equal to plus or minus 6 root 2. All right. So these, the more you deal with them, the faster you get at them. Now, if you had something like this, you kind of apply it. If you know the surface area is 37.5, the surface area of the cube can be found using that formula. What's the length? Well, 6s squared is equal to 37.5, right? Divide. Now, you're going to take the square root of both sides. So you're going to have s is equal to plus or minus the square root of 37.5 over 6. Now, you have a decimal here, so you're not just going to be able to simplify this nicely. So what you would do at this point would be kind of plug it into a calculator. Right, you would plug it into a calculator and write it as a decimal, okay? So, what do we know about it? We know, right, that this is 37.5 divided by 6. It's going to be around, right? This is going to be a little bit more than 6, so the square root of a little bit more than 6. So, your number is going to be plus or minus 2.3, right? It's going to be close to that. Let me actually see what it is. Square root of 37.5 divided by 6. Oh, it's actually 2.5. Huh. What's 37.5 divided by 6? Oh, 6.25. How nice. Anyway, plug that in, it actually ends up quite nice of 2.5. How lovely. All right. Should have done that one out first. All right. So what happens if you have to add or subtract? Well, again, naturally, guess what you're going to do? Add first, then divide, right? Same process. Same thing you would have figured out to do. Okay. Now, so for something like this, right, plus 19, 144 plus 19, right, negative 5x squared, 163. Oh, we have a negative. This is a positive, right? It's going to end up being negative. No real solutions. Yay. Okay. So how do I know that, right? Well, x squared is equal to 163 over negative 5. I have a negative that is left, so I'm not going to be able to take the square root of that. Something like this. Let's subtract that. We get 3x squared equals 192. 192 divided by 3 is 64. So x is going to be equal to plus or minus 8. All right, simple enough. Now, there are a few word problems that you can do with these. They're all basically going to be related to each other and you having an x squared and things like that. I'm not going to go through these ones, but you can go through the process. You just have to be careful and make sure you remember to watch your square roots. All right. The only other thing that I do want to very quickly mention, I'm going to go just pop right up here. The only other situation that you could potentially encounter is, let's say you have something like this. Uh, 21, whatever. Right, just be careful. If you take the square root of both sides, you get x minus 5 equals plus or minus root 21. So you get x equals 5 plus minus the square root of 21, right? And this would actually be your answer. I do just want to give you a quick little heads up about that because that's kind of like almost our precursor into what's going to be coming next. But I just wanted to kind of have that on your radar. But anyway, let me know if you have any questions and have a great day.